Hello and welcome to my video. It has been quite long since I made my last integral video, so here I am going to solve one problem related to integral. The problem itself is quite simple. We have to calculate the area of the region on quadrant 1 enclosed by these three parabolas. Y equals x squared plus 1, y equals 1 over 2x squared plus 3, and y equals 1 over 3x squared plus 7. So obviously, in order to find the area between or under the curves, we need to use the integral. But first, let us get a big picture first. Note that all three parabolas are symmetric with respect to y-axis, which means that their axes of symmetry are all x equals 0. And the y-intercepts of the parabolas are 1, 3, and 7, respectively. One more thing, if the absolute value of the coefficients of x squared becomes smaller, then the parabola increases more slowly, which means that the parabola is more spread out. Based on this knowledge, if we sketch these parabolas, we obtain this graph. As I said, these y-intercepts can be easily found from the equations themselves. We are looking for the area on the first quadrant, so we have to calculate the area of this region. So in order to calculate the area, we must use integration, but in order to determine the intervals of integration, we must first find out the coordinates of these intersection points. And in order to do that, we have to solve the system of equation using these equations of parabolas. Okay, let us find the intersection points between these parabolas. First, the coordinates of the intersection point A can be found by solving this system of equations. So by equating these two, we have x squared plus 1 equals 1 over 2x squared plus 3. So we have 1 over 2x squared equals 2. So we have x squared equals 4. So we have x equals plus minus 2. But here, we only choose x equals 2 because this point is on the first quadrant, so x must be positive. And from this first equation, y equals 2 squared plus 1, therefore we have 5. Therefore, the coordinates of intersection point A are 2, 5. And we can basically do the same thing for other intersection points as well. From this, we obtain x equals 3 and y equals 10. So the coordinates for point B are 3, 10. And from this, we obtain x equals 2 times square root of 6 and y equals 15. So the coordinates for point C are 2 times square root of 6, 15. Alright, so we have obtained these coordinates. Also, let us denote these feet of perpendicular on x-axis, D, E, and F as well, because we are going to refer to these points as well. Now let us calculate the area A of the shaded region. This area can be calculated like this. This area is given as the area of the region ABED plus the area of the region BCFE minus the area of the region ACFD. So the region ABED can be calculated as integral of x squared plus 1 dx, where x is from 2 to 3, and the region BCFE is integral 1 over 3x squared plus 7 dx, and the x is from 3 to 2 times square root of 6. And finally, the third region is given as integral 1 over 2x squared plus 3 dx, and now x is from 2 to 2 times square root of 6. So if we integrate this, first we have 1 over 3x cubed plus x here from 2 to 3, and we have 1 over 9 x cubed plus 7x here from 3 to 2 times square root of 6, and we have 1 over 6 x cubed plus 3x here from 2 to 2 times square root of 6. So if we calculate all this, for the first one we have 22 over 3, and for the second one we have 58 times square root of 6 minus 72 over 3, and for the third one we have 42 square root of 6 minus 22 over 3. And if we calculate this, we have 16 times square root of 6 minus 28 over 3. And this is the area of this region. And that was all for this video. Thank you for watching, and please like and subscribe for more math videos, and I will see you in another video.